So I was just gonna hone a bit on the materials part, right? Because the benefit of CEREC is, of course, we can see what gets milled on CEREC systems, right? And they're kind of largely three material classes. There's LiSi, which is dominated by Emacs, right? Great material from Ivoclar. There's zirconia, right, where Nespresso Rona is pretty strong. And then there's also composites, right, which is more the GC space of the world. If you look at different markets in the world, the material usage differs quite a bit, right? In most advanced markets, it's still mostly LiSi or Emacs. Zirconia is catching up dramatically. We can actually see it. Somebody who has a prime mill tends to mill zirconia more than lithium disilicate.
Hmm.
Right? There's a real swap, in particular in Australia, New Zealand, and the US. And then there are markets that use quite a bit of composite, right? Japan is notable for doing a lot of composite crowns, but it's also a thing in some Southern European markets. Now, if you look at these three categories, glass ceramics, so LiSi, zirconia, and composite, we have to compare apples to apples. What you get out of a printer is a composite crown with a certain degree of filler, but it's a lower amount of filler than on a composite crown that you can get out of a mill. Most dentists in the world that work chairside prefer glass ceramics or zirconia and only use composites for temp crowns. So then it's really a question on, if composite crowns are so great, why are you not using it on a mill today? Because if you look at the workflow of a printed crown, it's going to take you about half an hour if you include printing, washing, manual work, curing, and so forth. You can get a milled composite crown out of a CEREC in under 5 minutes and you're done.